We always think about planets as being, rocky like the Earth, or huge gas giants like Jupiter.
Right.
But the more we learn about other solar systems and other planets out there in the galaxy, the more it seems like maybe our solar system's actually kind of unusual. There are all these different types of planets that we don't see anywhere near us.
Absolutely.
And today we're going to do a deep dive into a couple of those really intriguing planets.
Yes, these are planets that orbit a star called TOI 1453, which is about 250 light years away from us in the Draco constellation.
Okay.
And this system has two planets that we're going to talk about, a super-Earth and a sub-Neptune.
And I think a lot of our listeners are probably familiar with these terms, but just to remind everybody, when we say super-Earth, we mean a rocky planet, like Earth, but bigger.
Yes, significantly larger.
And when we say sub-Neptune, we mean a planet that's smaller than Neptune, but probably a lot more gassy, a lot less dense than the Earth.
Yeah, right. Exactly.
And these kinds of planets, super-Earths and sub-Neptunes, they're incredibly common throughout the galaxy, but we don't have any in our solar system.
Right.
So that makes them all the more interesting.
Exactly.
So today, we really want to dive into, what makes these planets tick?
Yeah.
What are their key characteristics?
Yeah.
What can they tell us about the way that planets form and evolve?
And to do that, we're going to be looking at a report that was published in the journal Astronomy and Astrophysics from a team at the University of Liège.
Okay.
They use data from NASA's TESS mission, which detects planets as they pass in front of their star.
Right.
And also data from the HARPS-N spectrograph, which is used to measure the wobble of a star as a planet orbits around it.
Okay, so let's start with the first planet, this super-Earth.
Yeah.
They call it TOI 1453b.
Right.
So it's a rocky planet, like the Earth, but a bit more massive.
Yeah.
And its orbital period, its year, is only 4.3 Earth days.
Yeah, so it's very, very close to its star.
That is incredibly close. So it must be incredibly hot.
It must be scorching.
Yeah.
Yeah.
So then there's this sub-Neptune in this system.
Yes, TOI 1453c.
TOI 1453c. And this one, it's about 2.2 times the size of the Earth. So significantly bigger.
Yeah, noticeably bigger.
But the really surprising thing is that even though it's so much bigger, it only has a mass that's 2.9 times that of Earth.
Yeah.
So it's way bigger, but barely heavier.
Right, exactly. And the scientists who studied this planet, they say it's one of the least dense sub-Neptunes ever found.
So it's like a giant balloon.
Yeah, kind of. Like a balloon that's bigger than a basketball, but it weighs almost nothing.
What could it possibly be made of?
That's the big question, isn't it?
Yeah.
It doesn't fit the typical relationship that we see between the size and mass of most planets.
Right, so this is where it starts to get really interesting.
Yeah, this is where things get exciting because it suggests that maybe there are some really different ways that planets can form and evolve.
So how do they actually figure this stuff out?
Yeah.
I mean, these planets are ridiculously far away.
They are, but we have some very clever techniques for studying them.
Yeah, and we've talked about them on the show before, but it's always good to get a refresher.
Sure. So one way is the transit method, which is what the TESS mission uses.
Okay.
So as a planet passes in front of its star, it blocks a tiny bit of the star's light.
Yeah.
And by measuring how much the light dims and how often it dims, we can figure out how big the planet is and how long it takes to orbit its star.
Okay, so that's how they figured out that this super-Earth has a year that's only 4.3 days long.
Exactly.
But how do you weigh a planet?
Right. That's where the HARPS-N spectrograph and the radial velocity method come in.
Okay.
So as a planet orbits a star, its gravity tugs on the star a little bit, causing it to wobble.
Right, I remember that.
Yeah, and we can detect this wobble by looking at the star's light. The star's light will shift very slightly in color as it wobbles towards us and then away from us. And by measuring these shifts, we can figure out how fast the star is wobbling. And from that, we can calculate the mass of the planet that's causing the wobble.
Okay, so that's how they got the mass of the sub-Neptune.
Right.
And then they combined that with the size from the transit method to get the density.
Exactly.
That is so cool.
It is pretty amazing, isn't it?
Yeah.
We can learn so much about these distant worlds without ever actually going there.
So what are the implications of this surprisingly low density for the sub-Neptune?
Well, it's got scientists scratching their heads a little bit.
Yeah.
One of the lead researchers on the study, Manu Stalport, he suggested a couple of possibilities.
Okay.
One is that TOI 1453c could have a very thick atmosphere that's mostly made up of hydrogen.
Hydrogen, like the lightest element.
Yeah, exactly. So that would explain why it's so big but not very massive.
Okay, that makes sense.
The other possibility is that it's a water world.
A water world.
Yeah, like a planet that's mostly made up of water, either in the form of ice or liquid water.
Wow. So like a giant ocean planet.
Right.
That's amazing.
It is a pretty mind-blowing idea, isn't it? And it
Yeah.
really challenges our traditional view of what a planet can be.
Absolutely. And the study actually includes a diagram that shows the relationship between the mass and radius of different planets.
Yes, it's called a mass radius diagram.
Okay.
And what's interesting is that TOI 1453c doesn't really fit in with other planets of similar mass.
How so?
Well, most planets with a mass similar to TOI 1453c are much smaller and denser,
Okay.
so they would be more like super-Earths.
Right.
But TOI 1453c, it falls in a region of the diagram that suggests it could either have a very thick atmosphere
Okay.
or a lot of water.
So those are the two main possibilities.
Yeah,
A big puffy gas planet or a massive ocean world.
it's one or the other.
It's crazy.
It is. It's a real mystery.
So is there anything else interesting about these planets?
Well, there's one more thing. The researchers found that the two planets orbit their star in a very specific way.
Okay, how so?
It's called a 3.2 resonance.
A 3.2 resonance, what does that mean?
It means that for every 3 orbits that the inner planet makes, the outer planet makes almost exactly 2 orbits.
So they're kind of in sync with each other.
Yeah, exactly. It's like they're dancing together.
And that can't be just a coincidence, right?
No, it's not. These orbital resonances are thought to be caused by something called planetary migration.
Planetary migration.
Yeah, it's the idea that planets don't always stay in the same place where they form.
Okay.
They can actually move around within their solar system.
So these two planets, they probably weren't always in their current orbits.
Right. They probably migrated over time, and as they did, they got locked into this 3.2 resonance.
It's like a cosmic ballet.
Exactly. And it gives us a little glimpse into the early history of this planetary system.
And this isn't just about these two planets. This kind of research can tell us a lot about how planetary systems form and evolve in general.
Absolutely. It's all about broadening our understanding of what's possible out there in the universe.
So what's next for the research on these planets?
Well, one of the most exciting things is that the James Webb Space Telescope, JWST, will be able to study TOI 1453c in more detail.
Ah, yes, the JWST, our new favorite space telescope.
It's an amazing piece of technology, and one of the things it can do is analyze the light that passes through a planet's atmosphere.
Okay.
So when TOI 1453c passes in front of its star, JWST will be able to measure the composition of its atmosphere.
So will it be able to tell us for sure if it has a thick hydrogen atmosphere?
Yes.
Or if it's a water world?
Exactly. If it detects a lot of hydrogen and helium, that would support the thick atmosphere scenario.
Okay.
But if it sees a lot of water vapor and maybe not much else, that would point towards the water world scenario.
Wow. So we might actually be able to solve this mystery in the near future.
Yeah, it's an exciting time to be studying exoplanets.
And it's amazing to think that this one planet, TOI 1453c, is really challenging our understanding of planetary science.
It is. It's forcing us to rethink what we thought we knew about how planets form and what they can be made of.
Yeah, and that's what makes this research so fascinating.
Absolutely. It's the thrill of the unknown, the possibility of discovering something truly new and unexpected.
And this discovery, it also highlights the fact that our solar system might be a bit of an oddball.
Yeah, it's true.
I mean, super-Earths and sub-Neptunes are incredibly common in other solar systems, but we don't have any.
Right.
So why is that? What was different about the way our solar system formed?
It's a great question, and one that scientists are still trying to answer.
Yeah,
But it just goes to show that there's still so much we don't know about the universe.
absolutely.
Right.
So let's recap what we've learned today.
Okay.
We talked about a star called TOI 1453 that has two planets orbiting around it.
All right.
One is a super-Earth,
Yeah.
a rocky planet that's bigger than Earth,
Yeah.
with a super short year of only 4.3 days.
Exactly.
The other is a sub-Neptune,
Right.
which is even weirder because it's way bigger than Earth, but barely heavier.
Right.
And this low density suggests that it's either a giant gas planet or a massive ocean world.
Yeah, it's one or the other.
And to top it all off, these two planets are orbiting their star in a 3.2 resonance,
Yeah.
which means they're locked in this gravitational dance.
Exactly.
And all of this was figured out by studying the light from this distant star.
It's pretty incredible, isn't it?
It's mind-blowing.
Yeah.
And it really highlights the power of science and technology to help us understand the universe.
Absolutely. We're living in a golden age of astronomy, and it's only going to get more exciting from here.
I can't wait to see what we discover next.
Me neither.
So, for all of you listening out there, here's something to think about.
Okay.
We know that super-Earths and sub-Neptunes are super common in other solar systems,
Yeah.
but we don't have any in our solar system.
Right.
So what does that tell us about the way our solar system formed? Was there something special about the conditions here that led to the formation of the planets we see today?
It's a mystery that we're still trying to unravel.
It's a big question, but maybe someday we'll have the answer.
I hope so.
Until then, keep looking up and keep wondering.